it's time to clean up this effect and create a final compound. I'm going to go full screen on the ice tree and clean up any unnecessary nodes that aren't being used. So my execute node is unused, and everything else is in use somehow. I also need to pull out the items that are literal strings, so these get data nodes that are getting the birch tree, as well as the leaf killer for testing inside the null. I'll pull out. I also need to get the ground that I'm testing for collision with surface. I'll pull that out as well too. And I can actually move my set instance geometry up to where it belongs. Okay, after a last cursory look, I think everything is good. So what I'll do is create the compound, make sure that both of these inputs are terminating properly. So we'll insert an execute node between the ice tree and the state machine and emit. So I'll bring that back here. And then I'll select all of the compounds or nodes and create my compound. So right click and I'll create the compound. So I've got some inputs already defined based on the objects I left outside. Bring those together. If I dive into the compound, I'll call this my leaf motion falling effect. Leaf falling and blowing. Maybe we can change this a little bit more. Leaf blowing, falling, sticking. Okay, again, I'll add that into my category of ice tools. And now I need to expose certain inputs. Looks like I deselected there temporarily. Let me grab that again. Bring this back, jump into edit mode. Okay, what do I need to expose here? Well, I need to expose the reference for the set instance geometry, also the weight map that would be filtered. So I'll expose those inputs there. We'll expose the reference. So I'll just make some notes here. That's my weight map. We'll get the reference for the set instance geometry. If we have to index into the hierarchy, into the group of objects, make sure we grab that. And the hierarchy mode, whether or not we're dealing with hierarchies or simple nodes. So we'll say child and parent. And then on the emitter itself, if I expand it, we'll definitely want to be able to control the number of particles and the size. The initial color we're not going to need so much. And the speed I'll be setting to 0, so we don't need to worry about that. So I can adjust these. That's particle rate, particle size, and we can kind of move down the list here. And when it comes to the turbulence on the particles, we can go in and control the turbulize rotation using the min-max values. So we'll establish those. And if we look inside the turbulize rotation by cone, these are basically setting the twist and the start and end angles. So we'll call that twist. Twist. This is a start angle and end angle. The randomization per axis, I suppose I could... Yeah, that probably makes a good sense. This is the random scale per leaf, so we'll go in and focus on that. So min-max x, min-max y, and min-max z. Z. Go y there. Looks like I'm missing one. Yeah, there it is. Hold on one second. I'm just having to remove some of these ports here. I did this improperly. Okay, so let's go through this again. So we'll expose a port, min value, max value. So this is min value x and max value x. We'll expose the y min and max, and finally the z min and max. Okay, so that takes care of our size. As far as the instance animation goes, we really need to be able to control the start and end frame of our loops. So we'll call animation start frame, animation end frame, and the looping method is important, whether it's clamped or looped. And as far as the playback speed multiplier goes, we're using the randomized min-max values for that. So we'll call that animation speed min. And animation speed max. As far as our test inside null goes, our null is outside of the compound, so that's actually null name right here. So for null name, we'll call this the volume test null. So the get closest location on geometry, this would be representative of the emitter object. And this is the actual particle emitter. And for these group of nodes down here, we don't really need to access any information from it. We might want to change the stick location, whether it's based on collision location or an input, so I'll maybe expose that. And if we do need to access the input location manually, we'll have to expose that and perhaps the align to surface as well. We may even want to be able to control the collision method on our test collision with surface. So I'll expose this, the offset method, the offset distance, and the collision method. So that's a pretty large property page, but at least we've accounted for everything inside of our compound. I'll go into the compound properties, and this is my leaf blowing, falling, sticking compound V1. And I don't really need to add many notes to it, except that this creates the effect of a leaf falling after being blown off a tree limb. The leaves will stick to a surface based on collision. So I'll export that, export the compound, leaf blowing, falling, sticking. So it's nice now that I have this effect anytime I need to use it. test it one more time. And the reason they're obviously not falling is because my grid wasn't in the correct plane. There we go. So let's see how all of these guys fare after they fall into the ground. So everything looks pretty good. And we're going to finish our tutorial off here. We've covered a lot of ground in this tutorial, and I hope you're starting to understand the ice framework a little better now and are able to try variations on these techniques on your own. So I hope you enjoyed this one, and we'll move on and implement the rest of this compound into one of our older scenes.